Hello, everyone. With this video, I go over the congruence properties applied in the modular calculation, especially with calculation with large exponents. And usually those calculations, even though the concept is simple, but it can't be easily calculated even by hand or even with a calculator. So first of all, what does congruence actually mean? Let's remind you the congruence of two numbers, and actually use the same remainder. Okay, simple you divide, they have the same remainder. So then the two number congruent under n. For example, 11 and 24 are congruent under 13 by 13. So which means if you have to do the mod, 13 with the 11 and 24, they both have the 11. So these two congruent. When you write them together, you use this symbol, the two number, A and B are congruent. So you write like this. So that doesn't mean they equal. They mean you divide this by n mod, A will get the same remainder. And so this is the important property, or this is actually the definition of the congruence means two numbers. Now, if you have another number also congruence, you can easily show or and that the multiplication property of congruence, A and C multiply together and B and D multiply together is still congruence. All right, so it's equal. So this is the property we're going to use. And from that, we can easily prove that the following lemma. So from here, you can derive, although we are not going to require you to derive these properties, but this can be used. We're going to use this one and multiplication property of congruence, which means if you have two number multiply, you do the mod first and then do the mod and equal to the multiplication. Hopefully simplify the problem and also can easily generate with the exponents, you have these properties. It all can derive from here. In addition, you have several other properties, addition properties. If two numbers are congruent, which means, once again, they yield the same result. This is the number used, symbol used called congruence. So not identity or not defined. So the congruence, and then you add a constant, it's still congruence. And also you can easily show just based on definition over here. If a number add n times k, which means it's the same as that, which means you can change the problem. Okay, instead of find mod of n, you add a number of the divisor times an integer, and that's the remainder is still the same. That just can be easily proved by the definition of congruence. So, and for example, let's apply these two. So this one and this one, and we apply these properties. Okay, for example, if you want mod 28 mod 13, and simply you multiply is same as you minus 2, that's an integer k, times 13, the divisor, and that give you a 2. So then mod is simply 2. So remember you do this. Of course, you can do any of this. So you can say 200 times 13 is same. So, and then you apply the other properties. If you can say about 28 to the 7th. Okay, if you really want to do it by hand, you have never learned this, and this is a huge number, and you divide, you find the remainder. Of course, if you've got a time, you spend half a day, you can find out the question, but even by hand. But most of the calculator cannot hold this number in integer. So you have to use the properties, and then we use this properties here one more time, and then you will have 28 mod 13 Okay, and so therefore you mod 13 first. Let's apply these properties. So add these properties and then apply this one to here. Okay, and then you accept and do the mod first. Whenever do mod, it becomes smaller number, and then you do. And then additionally, to mod this, you can say actually that's 2. So you can actually 2 mod, and then this you can even do by hand or by simple calculator. Remember, most of the calculator um, you cannot do this huge number, but you can do this smaller number. Just to remind you, in exam, you're not allowed to use computers, but you are allowed to use calculator, especially some calculator has directly mod calculation. But unfortunately or fortunately, you cannot calculate this huge number. There's a limitation. But at 2 to the 7, you can simply press a button. It's allowed. And important is to apply these properties to reduce the problem to the simple question. So then, so this is actually 17 or 11. I don't know, because you can try. So that's how you do this problem. It's much easier. So in here, we applied 2 problems. In addition to this, remind you, you can basically change the base by this addition properties. Okay, change the base. So then this by this property, you change the base. So I apply this to here. So what's about a negative number? Okay, normally negative number, the mod is defined as a positive number. So mod 17, mod 13, the result is always between 0 and 12. So if you have, say you have negative 2, and which actually means it's not directly defined, but by the congruent rule, you need to add 13, whatever multiple, and then you have it will be 11. So negative number is defined. Mod of a negative number is also defined as the corresponding or congruent positive numbers. There are millions number of them. All right, one more example. We'll finish this video just to enhance. So this is actually one of the homework problems. Okay, 11 to the 20 is mod. Yeah, I'm definitely not asking you to directly do it by hand, not even with calculator. In fact, you have to use one of these properties, in particular this one and one of these addition rules. So for example, you can always separate into exponents. You're good at this. That's discovered in pre-calculus. And you can do this, separate the power exponent rule, 4 and 16. So the exponents become smaller, and hopefully you can even spot the answer. But if you cannot do this, but in this particular example, and remember, some ask why you want me to do such complex problems. Well, is there an easier way? Well, there is an easier way. But in fact, now you can actually use a computer program to do that. But why would ask you to do so much complex problem? The tedious. Well, and since you're a computer science major, you got to do it once or twice, so you know what exactly to do it, and then you can write a computer program to do this, and you are in a position of writing a computer program, so you must do it at least by hand, at least for a couple of problems. So this is the idea. So to reduce the exponents, so this is 4, but in fact the 11 to the 15th you still cannot do, and so then that is using the multiplication rule properties. You can do that, and that's application of that multiplication rule. So you do the mod separately, and that you give 3. That with a calculator you can get that, and this you still cannot do it, and you still separate it. You see, I do a very complicated way. Actually, I did it by hand. I know that is 4, and it's just to this 4. In fact, that's in other words, you can separate it different ways, right? Because multiplication rules. Actually, this way I went a long way, and So, but I did separate, apply the rule, then yeah, that's 3, and actually I got 3. This part is 3, and then this part 3 times 3, and I got a 9. So basically, let's make it simple. And or here's another way to do it, and actually much simpler. And so I use this addition properties, change the base from this minus 13, actually minus 13 to 2. You have that. So negative 2 and to the 20, and of course that's positive 2. So that's, I just use the math, so that's positive 2. And the same question. Okay, it doesn't mean this equal to that, but it means it's congruent. Okay, and then you have, I separate first, you can separate this different ways. I try to separate it this way, and or I can try to separate it this way, and then finally realizing that I can simply separate this 4 to the 5th, right? So it's 20, right? So to 8 is further, and then find all 5 or 6. So therefore, each of this, each of this, 2 to the 4th. So that's like this, to the 5th. Okay, 4 mod 3 to the 5th. And so that is 3, and then you do that. And of course, pressing calculator, you will get this, 9. So, and it's not unique, but once again, if you ask me any easier ways, but I wouldn't not ask you to do so complex problem, because you know that whenever you have a mod 13, the final answer is 0 to 12. Okay, and you can reduce the problem, you can reduce the base, separate them into different exponents. As long as the question can be handled by a calculator, and then you get easy calculation. In the exam, I will ask you to write down not just write down the final answer. Okay, and then I want you to show the steps. Okay, but in real life, you don't do this on a daily basis. You don't need, but then you should, but you're a computer science guy, a computer science person, you should be able to do this by hand if you are required to do. Then you should then do this, and maybe you're in the position of writing computer program to do this, but you've got to be able to do it yourself. All right, hope that helps.